And welcome everybody to our bonus features segment looking at the total electron content forecast here, showing you the most likely locations for GPS errors. And we've got quite high levels of electron flux here, and we've got some charging hazards. We'll get to it. We are certainly seeing some feedback in our weather satellites. Make sure you check out our meteorology segments. They typically premiere before the daily space weather videos. So these are the most likely locations to see GPS errors, folks. People that live at the equator are aware that your GPS will not work around noontime, especially. We are seeing some chaos here, some nighttime GPS errors around Antarctica. It's the total electron content forecast. So what we're looking at here is the electron content in the plasmaspheres and the inner Van Allen belt. So this is a plasmasphere, this is another plasmasphere, and that's the inner Van Allen belt. Your GPS satellite's located here at about 12,500 kilometers, 12,500 miles of altitude. And here we've got some significant charging hazards here. So some surface and internal charging hazards here over the Central Pacific, and some major internal charging hazards here over the Indian Ocean. So internal charging is caused by the higher speed, the higher energy electrons getting into the internals. Surface charging is caused by the lower energy electrons showing up on the surface. Expect some errors with your satellite communications and so on from that. There's the one-year chart to put the electron content in context. We can see this upswing here in the past couple of months in the electron flux. Here's the 3-day chart. And we are back into warning levels again, getting over 10 times warning levels for the past 2 days. If you look at the past 7 days, you can see that uptick there in that scale as well. We usually show the 3-day chart, so there's the 3-day chart. Here's the forecast model, and NOAA expecting a little bit of a downtick in the electron flux. I would tend to agree. No arguments with that. Next, we'll show the ionosphere layer, the bridge between Earth and space, located at about 300 kilometers of altitude. The F layer is what we're looking at here in vibrational frequency. So some high-frequency ionosphere there in the South Pacific. High-frequency ionosphere in general here, making it up to 14 megahertz. Anomalies are not that major at the moment. We'll show you the anomalygram next. So here's the anomalygram showing anomaly in megahertz from the 30-day median. Some pretty big swings here over northern South America there. You can see swings from high to low frequency anomaly. Also over the Central Pacific. And let's show the latest image. There's the latest image on the ionogram. That's 12:30 universal time. And there's the latest image on the anomalygram. Again, 12:30 universal time. Some low and high frequency anomalies happening there close by over the West Pacific. I'd like to welcome every one of you to the Neo Renaissance. Congratulations on realizing our channel exists. We're not selling dogma here. We're being critical about science. Remember folks, science is never settled, and science is not and never will be a consensus. Thanks to everybody who visits our sites. Perhaps pick up some merch. You can find links there as well as to our forum and to the Smash team. Here is the merch in order of best selling. So we're going up the list here since we've seen some shakeups lately in the best selling merch. Maybe it's happening now. Are people buying the merch? Who could have guessed? It's well designed, it's high res, it's poignant. Make Earth not suck again by picking up some merch. Also join us on Twitter, twitter.com/smashomash. You'll find stuff nobody else gets to see if you follow us over there. And if you enjoy the content and prefer to see it remain publicly visible and free for all to view, become a member of the Smash team at smashomash.com/smash team. Links below the video to that as well as on the homepage. There's a teaser as to our latest posts for gold level members. That's $9.99 a month. And let's look at some additional ground-based solar observatory data. So taking a look at the view from Cerro Tololo, we see massive numbers of filaments on the earthly side of the sun. Remember, folks, you don't need to see a solar flare to see a coronal mass ejection. We covered it repeatedly We started the channel just before the solar minimum of 2019, about a year before that, really. And yeah, we're like 4 years in, 4+ years in. Look at all of the filaments. Massive number of filaments here. Don't be surprised to see earthly coronal mass ejections. If you're wondering if we can forecast coronal mass ejections, the answer is yes. But since we're not paid to do it, we've decided to cease. So next we're going to show you the latest intensity gram. There's sunspot 2941 setting. There's a beta class group. That is an alpha class group, I believe. And we've got a major beta class group down here. That one's looking like it's actually doing some activity at the moment. You can see this little light bridge going across that leading umbra. Also some penumbra showing up there. There's another beta class group. There's another beta class group. And there is yet another beta class group. So quite a lot of sunspots, folks. Looks nothing like a grand solar minimum. To all of those who hypothesized about grand solar minima, you could probably put that one to bed, because this looks nothing like a grand solar minimum. If you're expecting no sunspots for days and days, we're at, I believe, 67 days without a lack of sunspots, if that makes sense. Next, the NASA GOES 16 SUV-I imagery. It's spectacular at showing solar prominences. Shout out to Erica Palmerio, one of the folks whose tweets we've been sharing on Twitter. So it looks like some activity kicking off down here in the southwestern limb as we make the video. We may have to make another video if that produced, especially if it produced an earthly directed coronal mass ejection. It could be splashing back down. It's a little too early to tell. It looks like it's actually going on as we record the video. A great wavelength to view solar flares is 94 angstroms. Here it is in all of its glory from the SDO. Most likely location for a major flare is still from sunspot 2941. Even after it goes out of view, folks, it can still produce major flares for a day and a half or so. Of course, it can still produce them regardless. It's just I'm talking about ones that are visible from Earth. And we'll close out the bonus feature segment here with 171 angstroms. Thanks for tuning in, folks. Congratulations on realizing the channel exists. And may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.